Today we are going to learn about algebraic relationships in tables. The first thing we need to do is establish our vocabulary words. The first one is variable. A variable is a symbol, usually a letter, used to represent an unknown number. An example of a variable would be the letter x. Next, we have independent variable. And this is also known as the independent quantity. We call this the input value. It can be any number you choose. And then finally, we have the dependent variable. This is also known as the dependent quantity and is called the output value. This number depends on the input value, which is why we call it the dependent variable. We can use a table to see the relationships between the input value and the output value. So let's look at this one. The output is 8 more than the input. Complete a table for this relationship to identify the dependent quantities. We will use x for the input. The rule is x plus 8, which means we will need to add 8 to each input value. The first thing I want to do is make sure that I know my input is the independent value and my output is the dependent value. So I write those above the table. Now the rule is x plus 8. Well, if my input value is x and x equals 10, then I will need to do 10 plus 8 to find my output, which is 18. I can do the same thing, but with 12 as my input. So if 12 equals x and x plus 8 is going to give me my answer, then I would do 12 plus 8 to equal 20. Why don't you go ahead and try the last one on your own, and we'll check in class tomorrow. In this table, the output is 5 times the input. We will complete the table for this relationship to identify the dependent quantities. We will use x for the input. The rule is 5 times x. Multiply each input by 5. The first input value that we are given is 4. Now the input value is x, so we're going to do 5 times x. In this case, it will be 5 times 4 to get the output, which is 20. Go ahead and solve the other two on your own, and we will check together in class tomorrow. In this problem, we need to identify the independent quantities for the table. In order to do this, we can work backwards to determine the input. If the output is found by multiplying by 2, then the input is found by dividing by 2. Now remember, the input is the independent quantity, and the output is the dependent quantity. We're given dependent, we need to find independent. Well, the rule is 2 times x equals the output. 2 times x is going to equal 10, so 10 divided by 2 will give us the x value, which is 5. So the input is 5. 2 times 5 equals 10. Let's try one more together, and then I'll have you do the last one on your own. 14 divided by 2 equals 7, so the input value is 7. 2 times 7 equals 14, so we know that is correct. Do the last one on your own, and we will check together in class. We can draw models to help us see the relationships between the input and output values. In this table, we have some pictures or models, and in this first one, you'll notice that there are just 2 little gray squares. Now the rule for this table is going to be 2 plus x times 2. So let's see what we find with each one. The input for the first one is 0. And then in our picture we just have those 2 little gray squares. Nothing has changed yet because this is the original picture, so when what is changing we're going to put 0 because nothing has changed. What is staying the same? What is constant? Well, the only value that I see there is 2 because there are 2 little gray squares. So I'm going to put 2. The output will be the total number of squares, and there are just 2 squares right there. And then of course my ordered pair is my x and y value, so I'm going to have 0, 2. And then the rule for this picture, the problem, is going to be 2 plus, remember we said x times 2, so that's 0 times 2. Let's try it with the next one. Now I see that I have the 2 original gray squares, but we've added 2 white squares. So what has changed in this picture? We've added 2 white squares. What has stayed the same in this picture? 2 gray squares are still there. How many squares are there total in the picture or in the model? There are 4. So my input value, or my x, was 1. My output value, or my y, was 4. So my ordered pair is 1, 4. And then if we write the rule or the problem, that is 2 plus, and that 2 represents those 2 little gray rectangles. And then I'm going to do the input value, which is 1, times 2. So we have one group of 2 white rectangles here. Let's try the next one. In my picture, I see I still have the 2 gray rectangles, and now I have 4 white rectangles. What has changed from the original picture? I now have 4 new squares. What is staying the same in this picture as the other ones before it? The 2 gray squares are the same. The output value is the total number of squares. 4 plus 2 is 6, so I have 6 squares total. And then I'll write my ordered pair, the input, output. And then if we write our problem or our rule, we have 2 plus the input times 2. So those 2 gray rectangles stayed the same, that's our constant, plus 2 groups of 2 white rectangles. If we look at the next one, the input value is 3. I see the same 2 gray squares are there. And then now we have 1, 2, 3, 4, 5, 6 white squares. So what is changing? Well, now there are 6 white squares. What is staying the same? The 2 gray squares are the same. The output, remember, is the total number of squares, which is 8. And then our ordered pair is the x value, the y value. So we're going to do the input, which is 3, the output, which is 8. And then if we write the rule, it's 2, which is those 2 little gray squares, plus the input, which is 3, times 2. Because there are now 3 groups of 2 white squares. Why don't you pause the video and solve number 4 on your own? We'll check it in class tomorrow, and then I'm going to talk you through number 10. Now let's look at the problem where the input is 10. There's not a picture there because that would be a lot of squares. And so really we're just going to write the rule. Now remember, our rule was 2 plus the input, which is 10, times 2. Now, what has changed is going to be the number of white squares. And we can find that by what's inside the parentheses, 10 times 2. And that's 20. There would be 20 white squares in that picture if we drew it out. What has stayed the same throughout the whole thing? That's the 2 gray squares. So we're going to have a 2 right there. Remember, the output is the complete total number of squares. So that would be 22 squares if we drew out the picture. And now we can write the ordered pair, 10, 22. Finally, we're going to graph the data that we have from our table that we just finished. Now, if you look at the table, underneath input there is an X, which means we're going to graph the input value along the x-axis. So we're going to label the x-axis input, And then in parentheses, I'm going to put independent, and you should do the same. And if you look at your table under the output, you'll see a Y, which means we need to label the Y-axis of our graph, output, and in parentheses, I'm going to put dependent, and you should do the same thing as well. Now what you will do is you will graph the first 5 ordered pairs from the table. You will not graph the last one, the ordered pair of 10, 22, because it will not fit on your graph. Go ahead and graph the other ordered pairs, and then remember that you need to answer your summary questions, and good luck!